Hello again, my name is Andrew Lake. For this video, we're going to go through a few application problems regarding perimeter and area and concepts that you've already covered in class and applying that to figures in the Cartesian plane. To get the most out of this video, you should try to take notes along as we go through it, just like you would in class. Um, and I think then when you try to do the review assignment attached to this one, you'll have a better uh, idea of how to do that. So let's start with number one here. So we're gonna consider like we're trying to make a yard for a dog that we have. And I have transplanted these points into a coordinate plane of where I think if I look like a top-down view of my house, where I would want a yard where each of these are going to be measured in feet. So the first one would be at 1, 7. So to plot that point, it's given to me as an ordered pair in XY. So I'd go right 1 and up 7, 2, 3, 4, 5, 6, 7. To plot this next one, I would go over 6 and up 2. And then to plot this last one, I would go right 1 and down 3. And that gives me my 3 points that are going to be the corners or vertices of my yard here. If I connect those to enclose what I want my yard to be, it makes a triangle. And then we're going to answer a number of questions regarding this triangle. The first question that we're going to ask is to find the cost of what it would be to make a fence around this yard if fencing costs $5 per foot. So in order to do that, what we would need to find is the length around the yard, or basically what we're asked to find is what is the perimeter of this shape. And if you watch the video at the start of this series, that should be something that you can do. To find the perimeter, to review that, I'm going to need to find the length of all 3 sides and then add it together. To find the length of the vertical side here, I can just count from -3 up to 7 is 10. To find the length of my diagonal sides, I can't just count. Instead, what I have to do is either the distance formula or the Pythagorean theorem. If I want to use the Pythagorean theorem, I'll use that to find this bottom one, and then I'll use the distance formula to find the top one. So to find the bottom one, again, the distance between these, I could make a right triangle in my coordinate plane here, where one leg of the right triangle would be 1, 2, 3, 4, 5. The other leg would be 1, 2, 3, 4, 5 as well. So if I want to find the hypotenuse, which is the distance I'm trying to find of this right triangle here, I would just do the Pythagorean theorem. A squared plus b squared is equal to c squared. So for us, our legs A and B are 5 and 5. So I do 5 squared plus 5 squared is equal to c squared. 5 squared is 25. 25 plus 25 is 50. And then the square root of c squared, or the square root of both sides, is the last thing that you'll have to do to get c by itself here. So we would say that c is about, if we grab our calculator and do the square root of 50, about 7.07. All right, let's round that to 7.1. So this is about 7.1. If I want to find this other one, the other way you could do that is to use the distance formula if you don't like the method that I just went through. To do the distance formula, remember the distance between any 2 points is the square root of the distance between your x values squared plus the difference between your y values squared. And again, it doesn't matter which of these points I call my first point or my second point for the purpose of plugging in this formula. You could just pick what you like. So I'm going to pick this to be my first point. So 1 will be x sub 1 and 7 will be y sub 1. 6 will be x sub 2 and 2 will be y sub 2. So if I plug those in, the distance here is going to be the square root of 6 minus 1 squared plus 2 minus 7 squared, which is 6 minus 1 is 5. 2 minus 7 is negative 5. But both of those, 5 times 5 is 25. And negative 5 times negative 5 is also positive 25. Two negatives make a positive. So that's the square root of 50. Hey, we know what the square root of 50 is. The square root of 50 is about 7.1. We just found that. So both of these lengths turn out to be the same. They're both 7.1. So the perimeter of this shape is going to be 10 plus 7.1 plus 7.1. Or what would that be? 14.2 plus 10 is 24.2 feet. Okay, now that's not necessarily the answer we're looking for here. So if our perimeter is 24.2 and it costs $5 per foot, then the total cost would be $5 times that 24.2, or what would that be? Would that be 97? 24.2, 24.2 times 5. No, 121. Oh yeah, I was thinking times 4. $121 is how much that this fencing is going to cost us. Yay. All right. Let's try to do, now that we know and have built our fence, the next thing that we would like to do is to build a gate in that fence. Oh, I cleared too much. Oh, hold on. Is there a way to reverse that? No, there's not. Ah, well, that's okay. Oh no, it's not okay. Ugh. Let me pause and put this back in. Okay, sorry about that. So now if we want to find the midpoint between, now that we have the fence built, if we want to find the midpoint between this 0.17 and this 0.62 so that we could put a little gate in our fence here, this is hopefully what you covered last week. To find the midpoint between 2 points, what you would have to do is add your x values together and divide by 2, and add your y values together and divide by 2. Basically, you're taking the average of your x values, the average of your y values. And again, it doesn't matter which one you call your first point or your second point. To be consistent, I'll stick with this is going to be my first point, and this will be my second point. So the midpoint here is going to be 1 plus 6 divided by 2, and 7 plus 2 divided by 2. Yeah, cool. So 1 plus 6 is 7, divided by 2 is 3.5, or you could leave that as 7 over 2. 7 plus 2 divided by 2 is 9 over 2, or 4.5. And again, that's fine, or if you told me the answer is this, that's fine too. So our midpoint is that, and then we could go and find that point and place our gate in our fence. So learn my lesson here. Let's just use the eraser. Okay, the next thing that we're going to do is find the area of this shape. And you can find the area of this shape using the method that we did in the second video in this series, which is to classify this shape and then use a formula to find it. So to review that, let's go ahead and review and classify whether or not the triangle is acute, right, or obtuse first. So to determine whether or not this is a right triangle or not, there are two tests that you could use. The first test that I'm going to try is if this is a right triangle, that I would suspect that this right here would be the right angle just by looking at it. And if that is a right angle, then these two lines would be perpendicular, which means that if this line here, let's call it L1, if that line has a slope of A over B, that this line, let's call L2, would have to have a slope of negative b over a. It would have to be the opposite reciprocal of our first slope. So I could tell what if these two lines are going to be perpendicular by finding their slope. And in order to find the slope between these 2 points, it's easy and fun. Just remember rise over run. So the rise between these 2 points would be negative 1, 2, 3, 4, uh, 5. And then the run would be 1, 2, 3, 4, 5. So my first slope is negative 5 over 5, or negative 1. My second slope would be have a rise of 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And look, those are opposite reciprocals from each other. Negative 5 over 5, if I flip that and change the sign, becomes positive 5 over 5. So in fact, those lines are perpendicular to each other, which means that this is a right triangle. And if you have a right triangle, you could find the area of a right triangle by doing the 2 legs multiplied by each other divided by 2. Um, okay, that was one test. Another test that you could do is you could do the Pythagorean theorem and do a squared plus b squared, and or I should say something similar to the Pythagorean theorem, where you do a squared plus b squared and compare that to the length of c squared, where c is your longest side. And then what you get is if they equal each other, then it's a right triangle. So if we go back and do the square root of 50 squared plus the square root of 50 squared, that would be what, 50 plus 50, which is 100, which equals 10 squared. If it turned out, however, that a squared plus b squared was bigger than c squared, and our c squared then became shorter, then what that would mean is that you have an acute triangle. And if a squared plus b squared was less than c squared, that would mean that you would have an obtuse triangle. And so that's another test that you could use if you like the Pythagorean theorem and you're good at that. You can use that to find what type of triangle this is as well. Okay, so the quick recap of what we covered so far. The expectation is that if I was to give you a system of points in a coordinate plane, you could find the perimeter of the figure that those points create. You could classify, you could find the midpoint between any of the two sides, and then you could also now hopefully classify what type of shape it is by determining whether or not your lines make right angles or not, because at least for a lot of the shapes that we'll deal with, you can determine what type of shape it is if you know whether or not it's if you know the length of its sides and you know whether or not its angles are 90 degrees or not. Okay, but I said the ultimate goal for this second portion of this is to classify the shape and then hopefully find the area of it, because the fourth thing we're asked to do is find the cost of resodding the yard. So the idea here is I'm going to replace all of the lawn that I have here, all the grass that I have here, with a new, like, I don't know, I had no idea about types of grass or anything like that. But I'm replacing it with the new ultra grass, which is just like regular grass, but it's ultra. And in order to do that, though, I need to know how much area my triangle covers, because it costs $10 per foot squared. So I have to see, do I have enough to get ultra grass? Okay. And in order to do that, again, I need to find the area. So now that I know this is a right triangle, I could find the area by doing 1/2 base times height, which would be, for a right triangle, the same as the length. So I could do 1/2 of 7.1 times 7.1, which is And actually, if I'm going to go back to type this into the calculator, you know what I'm going to do? I'm going to do this trick where I remember that I got 7.1 by doing the square root of 50. So I'm just going to do the square root of 50 times the square root of 50. Oh, golly. Times the square root of 50 times 1 divided by 2. So that gives us an area of 25 square feet. Another way you could find this answer is by breaking up the shape. Okay, red pen. By breaking up the shape and like reorienting it. Like imagine that we turned this 90 degrees. So this is the base, uh, the 10 side, then the height from the distance from this to the top point right here would be from 1 to 6 is 5. So I could do 1/2 of 10 times 5, and you know what that is? That's also 25. So I'm told I now know that the area of my yard is 25 feet squared. Sod or the resodding would cost $10 per foot squared. So the cost of resodding here is going to end up being $10 times by 25, which is $250. Okay, last thing that we're going to do now that we have fenced in the yard, we've put in a gate, we've resodded it with ultra grass, which I mean, all the neighbors will be super jealous when it's so vibrant, it's so green, and they're going to be like, "Whoa, how did you get your yard to look so like green?" We need to put in a walkway. That way we don't have to step on our ultra grass. I mean, we paid a lot of money for it. So what we would like to do is put in a walkway from one of my end of my yard to the other, and ideally going through this line that I plotted out that I wanted to go through y equals 2 and determine where that's going to intersect the triangle. And then determine how much it would cost if the price of putting in that walkway is $15 for every 2 feet. Okay, so if we go back, and actually this red line here that I've already drawn is the line y equals 2, right? Like the line y equals 2 is a um, horizontal line. It passes through the y-axis at the value of 2. So this line right here passes through the y-axis at the value of 2, and that is going to intersect my triangle at 2 points. This point 2 2, and this point 6 2. And so that I'm asked to find how long is it from that point to that point for my stone walkway. And again, if it's just a horizontal line, I can find that distance simply by counting from 2 to 6, gives me a distance of 4 feet. So if I'm asked to find the cost of putting in that stone walkway, if it cost 15 per every 2 feet, then I would say the cost is, now the fraction here might, 15 per 2 might scare you, but really it's the same thing as we did for these two when we're finding the cost. The cost is simply going to be 15 over 2 times 4, right? And you could just type that into your calculator if you're like really nervous about fractions, but this is a fraction that you should be able to do hopefully without a calculator, right? If you really want to and go through all the work, you could turn this into a fraction and say that this is 15 times 4 over 2. And notice here that I could just divide the 4 by 2 and get that this is going to cost me $30 to put in the stone walkway. All right, so hopefully you should now be prepared to do the third assignment for this series. If you have any questions that come up, you can comment them and I'll try to answer, or you could simply ask your math teacher, or come back and watch this video again and hopefully catch some things that maybe you missed. Thank you for watching, and have a good one.